If you have ever attempted to build a production application using Blazor Interactive Server, you've probably run into Entity Framework Core's biggest constraint. DbContexts are not thread-safe. In a traditional MVC or Web API application, an HTTP request is short-lived. A scope DbContext is created, does its job, and is immediately disposed of. But Blazor Interactive Server is stateful. Your entire user session lives inside a persistent SignalR circuit. If you register your database context using the standard services AddDbContext, AddDbContextFactory, that instance stays alive for the entire lifespan of the circuit. The moment your user triggers two concurrent async operations, like processing a background file upload while navigating a multi-tenant dashboard, EF Core will throw a fatal exception. A second operation was started on this context instance before a previous operation completed. Let's look at how the C-Nex architecture solves this natively using .NET 10 and how we can swap our entire database infrastructure from SQL Server to PostgreSQL in under a minute. Inside the C-Nex infrastructure persistence layer, we abstract database configuration completely inside this extension class. Instead of registering a raw context, we use AddDbContextFactory. The factory allows us to instantiate clean, short-lived, isolated DbContext instances on demand inside our Blazor components, entirely bypassing thread safety and concurrency issues. But notice a critical detail here. We pass service lifetime, scoped as a factory lifetime. Why not the default singleton? Because C-Nex enforces automatic multi-tenancy. To register global query filters that restrict database queries to the current user's tenant ID, our factory needs access to scope services, like our custom iTenant service. A singleton factory cannot safely evaluate scoped runtime data. By making the factory itself scope to the SignalR circuit, we can inject tenant context cleanly during instantiation. Right below it, we register fallback. This guarantees that short-lived framework dependencies like ASP.NET Core identity pages, token endpoints, or minimal APIs get a regular, perfectly configured, tenant-aware database connection automatically without breaking standard MVC conventions. Now let's transition this entire system to PostgreSQL. If you are developing locally on Windows, head over to postgresql.org, download the interactive installer, and run through the steps. Make sure to note your master administrative password and the default port, which is 5432. Once installed, launch pgadmin or your preferred database tool. Right-click on Databases, select Create Database, and name it C-Nex v2_dev. This matches our development configuration. Hit Save, and your local Postgres server is officially up, listening, and waiting for connection traffic. Now for the magic. We look at our app settings development.json file. Right now, the database provider key is set to sqlserver. We are going to change that text string to PostgreSQL. Next, verify your Postgres connection string. Ensure the host is set to localhost. The database matches the one we just generated in pgadmin, and include your administrative user credentials. Because of our clean architecture boundaries, we don't have to touch a single file in our domain logic, change our service layer, or rewrite any data access logic. The provider configuration pauses dynamically at runtime. Before we apply this to the database, there is one crucial best practice you cannot skip: resetting your migrations. Entity Framework Core migrations are provider-specific. When you generate a migration for SQL Server, EF Core hardcodes SQL-specific annotations into the C# snapshot, things like identity column behaviors or specific indexing limits. If you try to push a SQL Server migration to a PostgreSQL database, it will likely throw schema errors. So, we simply delete our existing migrations folder. Then, we run .NET migrations at initial Postgres setup. EF Core reads our new Postgres configuration, analyzes our DbContext, and generates a brand new, clean migration snapshot perfectly optimized for the PostgreSQL dialect. Now, here is where the production readiness of the C-Nex architecture really shines. We don't need to touch the terminal or run a manual database update command. We just press F5 to boot the web host. Watch the console logs closely on startup. Inside our program.cs middleware pipeline, we instantiate an isolated startup service scope immediately after building the web host app. The framework pulls our fresh Postgres-configured database context factory outputs, checking for database migrations, and executes an asynchronous database migration completely on the fly. Right after the migration settles, it grabs our ASP.NET Core identity managers and triggers dbInitializer.seed async. It securely sets up default roles, provisions a baseline administrative credentials, and finishes with database seeded successfully. No manual CLI steps, no synchronization bugs between environments. The entire infrastructure self-heals and upgrades every single time the app initializes. The Blazor Server UI spins up instantly, completely backed by a healthy, fresh PostgreSQL database instance. This is how you eliminate operational friction and ship features on day one. That wraps up our dive into the database architecture of C-Nex. Thank you for taking the time to watch all the way through. Building stateful applications with Blazor Server and Entity Framework doesn't have to be a headache of concurrency errors, as long as you set up your foundation correctly from day one. If you found this engineering breakdown valuable, please hit the like button and share this video with other developers on your team. It really helps out, and it lets me know that you want to see more under-the-hood technical content like this. I'd also love to hear your thoughts. Drop a comment below and let me know how you are currently handling database lifecycles in your own .NET projects. But don't just take my word for how smooth this runs. I want you to test the architecture yourself. I've deployed a live production-ready demo of this exact template, so you can feel the performance. Head over to cnex.runask.net. You can log in right now using the email admin at cnex.com and the password admin at 123 with a capital A. Go in, poke around the dashboard, test the responsiveness, and experience the speed of a properly tuned .NET 10 application. Thanks again for watching. Keep building, and I'll see you in the next one.